All right, let's take a look at the trend that we see in the periodic table for electron affinity. So first of all, we have to talk about what electron affinity is. It is the energy that's absorbed or released when an electron is added to a neutral atom. And the general equation for electron affinity looks a little like this. So you've got an atom, and there's an electron added to it, and then it forms an ion, an anion in this case, plus energy. So whenever you have a reaction like this, there's an energy that's associated with it, either absorbed or released. And when something becomes more stable, energy is released. Okay, and I want you to keep that in mind. That's important for us to know in order to understand the trend that we see in the periodic table. So when you're moving from left to right, electron affinity increases. And just by looking at the number of valence electrons, we can kind of explain it, right? Lithium has one electron. If it gains another one, that's not really much use to it, right? But let's take a look at fluorine. Fluorine has 7 valence electrons. If it gains one, it becomes more stable. So in doing so, if it gains one electron, it releases more energy because it's becoming more stable. Okay? Now, it's very, very important for us to note that noble gases, all of them, have approximately an electron affinity of 0. Okay, so we cannot include, or we do not include, the noble gases in this trend, right? They don't necessarily gain electrons. They don't need to. They already have a full shell. Okay, now moving on to the trends that we see from top to bottom for electron affinity. As you're going from the top to bottom, electron affinity decreases, right? And this kind of makes sense because when the electron, this one extra electron, if it is added, if you're moving down the periodic table, it's added to a shell that is further away from the nucleus, right? So when it's further away from the nucleus, there's less of an attraction between the nucleus and that electron, which means that there's less energy that's released, right? So in lithium, the protons in the nucleus and the electron that's here, or the electron that's added, there's a stronger attraction. Whereas in something like potassium, if there's a one electron that's added here, there's a less of an attraction between that nucleus, the protons in the nucleus, and that one electron. All right, so that is the trend that we see for electron affinity.